Okay, let's do some basic factoring of polynomials. Here I have a polynomial. It is 2 terms. We've been over all of the terms in section 6, so now we're familiar that we know these are 2 terms. I am looking for something that is common. They both have x. So I pull the x out, and then in parentheses, I am left with 4x minus 3. If I use the distributive property and go backwards, I go back to 4x squared minus 3x. Second one, I'm looking at the 10, the 20, and the 5. Anything in common? Yes, a 5. How about the y's? I have a y to the second, a y to the third. Well, the only thing in common is just plain y. So I take out the 5y. 5y goes into 10y to the third, 2y squared times. Goes into 20y squared, 4y times, because 5 times 4 is 20, and y times y is y squared. 5y goes into negative 5y, negative 1 times, which means subtract 1. Now again, use the distributive property and work backwards and make sure you get your original polynomial. 5y was my common factor, my greatest common factor. Try one. 8x to the fourth plus 4x to the third minus 2x squared. Pause. Hopefully you chose 2x squared as your common factor. Times 4x to the second plus 2x minus 1. What happens here if I pull out a common binomial? In this case, I have 7 times x minus 3 minus 2x times x minus 3. Well, what's common, this whole left side is one term. Therefore, I can take x minus 3 out because it's in both. And I'm left with 7 minus 2x. If there is no common binomial, well then you can't do this and it cannot be factored. But in this case, x minus 3 was a greatest common binomial. Try one. Let's help you with this first one. 4s times s plus 6 minus 5 times s plus 6. Clearly, s plus 6 is in both. So I'm going to list s plus 6. But then I have my 4s and my minus 5. So I take my 4s and I take my minus 5, and that's my second binomial. Try this one. Do you notice that there's nothing in front of the second binomial? The 2x plus 3 has nothing in front of it. What do we put in front of a parentheses when there's nothing there? The invisible 1. My class is well aware of that. So if I put an invisible 1 there, that doesn't change anything. Because if I do distributive property, 1 times 2x is 2x, 1 times 3 is 3. It all stays the same. But what it does is it allows me to pull out the 2x plus 3 and the 7x plus 1. Try it on your own. Go ahead and hit pause. This one was a little more interesting. You ended up with 5x minus 2 times 5x minus 2. Well, guess what? When you have a base and it's repeated, the number of times you repeat it become the exponent. 5x minus 2 is my base. Happens to be a binomial also, but it's still a base. Squared. What if we want to factor by grouping? Usually there are 4 terms in order to do grouping. and you group them into twos. So grouping is good when there is no common factor for all of the terms. So I look at my first one and I see right away 12a to the third minus 9a squared plus 20a minus 15. Nothing goes into 12, 9, 20, and 15 evenly. So I'm going to group it. I take my first two because I know that 12 and 9 have a common factor. I know that 20 and 15 have a common factor. So I'm just going to work as if these are two separate problems. I end up with 3a squared as my common factor times 4a minus 3. I take out 5 and I have 4a minus 3. Well, rather coincidental, isn't it? But of course, you always know that the examples they give you are always so much easier than reality. But let me tell you, on a standardized test at your level, this is the type of question you will get. 3a squared plus 5 times 4a minus 3. Clearly, this does take a lot of thought, and you must keep looking for common factors at every step of the way. Take a moment, pause it, and take a good look at it. Here are some to try. I'm going to tell you again to pause the screen, write down these examples, and then I'm going to give you the answers, of course. Pause. Okay, my first one. I grouped the first two together, and the last two. I pulled out 2b squared here. I pulled out a 3 here. I'm left with the same binomial at the end, 2b squared plus 3 times 3b plus 4. Now, would it have mattered? My students always ask me, would it matter if I put them in a different order? You're going to see right now in this next example that it does not matter. I take the first two and the second two. I take 4r cubed plus 24r. I take r squared plus 6. I pull out 4r. Here I pull out nothing. There's nothing in common, which means invisible 1 is here. 4r plus 1 times r squared plus 6. Well, what would have happened if I had rearranged them? What if I had done 4r cubed plus r squared and I had picked two different binomials? Sorry about the dogs. If you're in my class, you know I have 3 dogs and they bark a lot. I've been very lucky up till now. So let's keep going. I have r squared plus 6 and I have 4r plus 1. Well, guess what? It came out to be the same answer. Does not matter on the order. Same way up here, I could have had 3b plus 4 first times 2b squared plus 3. It doesn't matter. What if I'm factoring with opposites? Okay, this is a little more complicated, and not everyone is going to understand this, but give it a try. 5 minus x is the same as negative 1 times x minus 5. How could that be? Well, here's my example. 2 times 5 minus x equals negative 2. So make the coefficient here on the outside of the parentheses the inverse sign times negative 1. Negative 2 times x minus 5. Do distributive property. 2 times 5 is 10. 2 times negative 1x is negative 2x. Negative 2 times x is negative 2x. Negative 2 times negative 5 is positive 10. Rearrange your terms because you're allowed to. Remember, they're like puzzle pieces. Negative 2x plus 10, negative 2x plus 10. Do not just say, oh yeah, that's easy, because it's not easy. I know it's not easy. The commutative property, though, lets you change the order, and inversing the sign and the order remember this, as long as you do one thing to both sides, it all works out. It does. So here I take 3x to the third minus 15x squared plus 10 minus 2x. Again, I'm going to need an invisible 1 here. I'm going to pull out 3x squared. I'm going to pull out 2. And I'm left with x minus 5 and 5 minus x. Gosh, they're so close, and yet they're not the same. So I could just quit and say it doesn't work. I can't do it. But guess what? You can. The coefficient becomes the inverse, and it reverses the binomial. So I multiplied this entire second half here by the negative 1. This becomes a negative 2. The negative x becomes an x. The 5 becomes a negative 5. Everything is balanced. And now I have x minus 5 and x minus 5 as a common binomial. Careful, careful, careful. This is not easy. Try one. Group, factor, look for opposites, factor out the binomials. Pause the screen. Here I'm showing you that if you multiply the whole second half by negative 1, you can get the common binomial 3 minus 2x. So 5x squared minus 4. And now, of course, I took this 3 minus 2x and I put it in the correct order by degree. Negative 2x plus 3. I rearranged these two values. If you don't see that, this was a 3 and the 2x, and I just realigned them. The commutative property allows me to do that. What would have happened if I had changed the first one instead, and I had done my negative 1 times this first set? No problem. You can do it. You can go ahead and change that instead. You're still going to get the same answers. When you go to do your FOIL, you're going to get the same answers. I suggest that you read over this another time because I don't think just hearing it once is enough, and I really think you need to do some examples. Good luck as always.